And we should be dealing with great problems and great minds. How do we escape the bubble? So, with this problem, we find ourselves in a society now where everyone seems to have their own ideas on everything. And I want to compare a little bit to how this was when I first started here at Illinois Tech. I came to Illinois Tech in August of 2000. So what I would like us to do today is jump back into our time machine and see what, when I was a young faculty member, that I had decided that I had wanted to work on. So if we go back to 2000, when I first started here, this was where I thought I was going to spend most of my career. I was going to look at energy, how we can provide energy to the country, how we can go about doing this, and why we want to go about doing this. One of the big reasons that I wanted to do this was because I was concerned about climate change. So, energy, where we're going to get our energy supply, climate change, where we're going to reduce carbon emissions, how we're going to change transportation, how we're going to fix the world. The third major issue that I thought was of great importance at the time was emerging disease. And so I thought emerging disease was going to be a huge area going forward, because I thought as the climate changed, we were going to quickly start getting to the problem where the tropics started encroaching on where people were living, and that we would have the opportunity for people to interact with some of these odd and unusual diseases and potentially bring them back. Now, it turns out these were three pretty good problems to work on, and I have worked on them through much of my career here at IIT. But if we come today, where do we stand now on all of these problems? So if I look in terms of energy in 2020, we have blackouts all across the world. California, Australia, we still use fossil fuels. In 20 years, if anything, we've probably gotten a little worse. And it's because we don't necessarily completely follow through with anything that we should be doing. We do things in a piecemeal fashion for many, many different reasons. So in California, they have issues providing enough power supply to meet the necessary demand that they have. People want to use electricity, they can't meet it. There's a blackout, they have to shut things down. The same thing has happened in Australia, where the infrastructure isn't quite up to par and can't handle shipping power across the country. So what happened recently in California on August 15th, they have the red curve that is demand. They have the blue curve, which is we call net demand, which is demand minus what wind and solar can provide. And in the late afternoon, there was a problem. They could not meet the demand that people put onto the grid. And they had to then rely on power outages, rolling power outages, to black people out so they could not utilize electricity because they couldn't provide it. One of the big reasons why this happened was because there was a big drop in renewable energy. In the late afternoon, the sun always starts to go down and you lose solar energy. And here, in addition, there was a big drop of wind in California, and they could not provide all the electricity that people needed. And this happens more and more as we replace coal and gas fired generation with wind and solar. Wind and solar, as anybody who's ever gone outside, can become somewhat unpredictable. A cloud can pass by, the wind can stop. And these are problems as we go through trying to guarantee our energy supply. It's not enough to meet the average supply. We have to have a supply that can meet peak and can be provided on demand. It has to have reliability. In terms of climate change, yeah, we're not doing so good there either. As of July 2020, we have 414 parts per million of CO2 in the atmosphere. When I was born in 1968, it was down at around 320 parts per million. So we're almost up 100 parts per million over my lifespan. And we're still going up, and we're not really doing anything in order to cut it down. Why is this? Because we like to burn fossil fuels. In 2000, when I started here, we burned 78.2 quads of fossil fuels. One quad is 1,055 petajoules, or 293,000,000,000 kilowatt hours. So that's 293 billion kilowatt hours. But I like quads because they come out to numbers around 100, so it makes it easy to work with percent. So we have not reduced the amount of fossil fuels that we use as a country. Why is that? Well, even though we've added wind and solar and other renewables, the amount of electricity that we use has also increased. Is that a question or somebody joining? That must be somebody joining. Okay, so 80% of our energy right now is still provided by fossil fuels. This is all leading to more carbon dioxide generation and increasing carbon dioxide. And also now, because we're using more natural gas, we're also putting more methane, which is also a greenhouse gas, into the atmosphere. So we are continuing along this path of climate change. Emerging disease was actually worse than what I thought. Over the last 2 decades, we've seen SARS, West Nile virus, Zika virus, which creates horrible birth defects. And obviously, 2019, I'm sitting at a desk tethered while I'm giving a talk because I can't move around because I got to stay in front of the camera because of COVID-19. These are all major issues that we should have been preparing for over the last 20 years, and especially since the end of the Cold War. And we did not. We chose to ignore this as a threat. That's not the greatest of all situations, unfortunately. Now, I'd say I told you so, but that would kind of imply that my career was totally worthless since I've spent 20 years working on many of these problems. And I don't want to think that my career has been totally worthless, even though we haven't really improved anything. I find that kind of disappointing in many ways. And frankly, it's now even worse than that. Because unfortunately, we keep adding new problems. And these new problems can often be as bad as the ones that I came here to work on. We have water wars. Now, the Western states have been fighting over water forever, mainly around the water flowing into the Colorado River. So in the Colorado River, we have a number of major cities in or just outside the Colorado River Basin: Salt Lake, Denver, Phoenix, Las Vegas, Los Angeles, San Diego. And all of these places get water from the Colorado River. The problem is climate change has affected how much snow gets deposited into the Rocky Mountains, which changes the amount of water in the snowpack, which changes the amount of water that eventually makes its way into the Colorado River. This has been a problematic uh, because these states have been fighting over this water since the 1800s, and the population has grown dramatically in the West, and the temperature has increased. It's now very common to see temperatures well over 100 degrees Fahrenheit in much of this area. And we rely on a lot of this area, especially the Central Valley of California, for food. Now, it's gone beyond the western states now, where the eastern states have gotten into the battle over water. So, Florida, Georgia, and Alabama are now fighting over water that Atlanta is taking. And so, farms in Georgia, the city of Atlanta, are taking water that used to go to Florida. These are all problems that we have to address. And these are problems that are at the interface of technology and humanity. Another major aquifer that's right in the heartland is since the year 2000. The aquifer has greatly decreased in size and the amount of water there because of irrigation. We are pulling water out now to utilize for farming from Nebraska all the way down to Texas. These are problems that we're going to have to address. Obviously, there's plenty of water on the planet. The question is, how do we make it drinkable, and how do we get it to where we need it? These are all going to be difficult problems that we have to face in the next 20 years. Fires are becoming rampant. If we look in 2018, we had the basically 100-year fire, which now happens every year in California, that killed 48 people, or oh, no, 56 people now, in Paradise, California. You can see the molten metal that puddled coming off of the car and rolling downhill until it solidified in the photo. There are a number of reasons why we see these horrible fires. Climate change certainly plays a role. How we live and utilize land plays a role. How we manage forests. How we push the population closer and closer to forests. This becomes a problem. So in Paradise, the fire popped up very quickly. They tried a rapid evacuation, but unfortunately, it turned very deadly. And so that's something else we have to deal with. How do we teach or train people to evacuate when they live in some of these dangerous areas? Now, in 2000, I went through a major wildfire like this. This was the Cerro Grande fire in Los Alamos, California. This occurred right before I moved to IIT. The bottom photo here is a picture from the roof of my house. I lived at the corner of a park. Right across from me was an empty lot, and the firefighters kind of made a stand at my house. And you can see that the fire burned all the homes across the way from the park, and behind my house, everything really survived. I had horrible water damage. They put so much water on my house that my roof collapsed. And that was one of the triggers for me to leave and decide to come here to IIT. But here we also had a fairly rapid evacuation, but at Los Alamos, the evacuation was very successful and there was no loss of life. And one of the differences was in Los Alamos, you had a trained population that was used to practicing evacuation drills. They weren't practicing for forest fires, but the ability to translate that knowledge led to a successful evacuation, even though it was rapid and probably started a little later than it should have. These are all problems that we have to somehow find solutions to. So, evacuations have been a nightmare within the country. One of the worst was in Houston, Texas, when they were preparing for Hurricane Rita. You had 2.5 million people trying to get out of the city of Houston, and they clogged the arteries, the expressways that allowed people to escape from the city. This is very problematic. And so it causes issues when we're not prepared for these things. And unfortunately, now we have fires, floods, and storms that are happening much more often as people utilize some of these coastal areas, some of these forested areas. And we have to think about how to address this, or if we're not going to ban these areas from being used, we have to somehow prepare for these evacuations that are going to occur. Around here in the Chicago area, apparently we don't know how to build a bridge anymore that lasts for longer than 20 years. So we have a tremendous problem with the amount of infrastructure that is getting to the end of its useful life. Obviously, we would like to build bridges that don't corrode in 20 years, but it's a problem. We have a lot of bridges that are right on the ragged edge of their useful life, and that is a major problem. How do we fix this? How do we build new bridges? How do we pay for them? Pipelines are another area. As we saw in California, we have blackouts. Well, we have a lot of natural gas in this country, and both of our presidential candidates have said we're not going to ban fracking. So, if we're not going to ban fracking, we're going to be using a lot of natural gas going forward. But if you don't provide the pipelines that get from where the gas is to the people who want to use it, it doesn't do you much good. So we have people protesting putting pipelines and more infrastructure into the ground. How do we deal with this? How do we make it safe to actually implement some of these necessary pipelines that we're going to need if we're going to continue relying on natural gas? Transmission lines. This is infrastructure that's just horrific. In the West, that campfire that we've already talked about was started by transmission lines that belonged to Pacific Gas and Electric. And so the transmission lines failed, lit the forest on fire, and killed 56 people. Well, now up to 84 counts. 84 counts of manslaughter. So these things are all problematic. And we have to cite these better. We have to build them so they're more resilient within their environments. Maybe we could bury them. There are a lot of things that we could potentially do, but we're going to need more transmission as we build out a super grid so we can take renewable energy from Seattle and take it to Florida or take it to California. If we're going to try and address the use of fossil fuels. And people still are a major problem. Here we are trying to build a high voltage transmission line in Pennsylvania, and people line up to protest it. They don't want it. People don't want pipelines. People don't want transmission lines. People don't want expressways. People don't want rail. How are we going to function? How are we going to get products from here to there? How are we going to get energy from here to there? This is a problem, and we have to come up with solutions that address this. Uh, right now, we have a lot of unrest in our major cities. We have protests, and on occasion, these protests become riots. And in Chicago, we haven't had quite the same number of riots, but we've had looting. What are some of the causes of this? How do we address this? Well, one of the areas that I think is very important is education. Our education system has major flaws. We've seen over the last few days that there are kids having to go outside restaurants like Taco Bell to use the Wi Fi because they've been forced out of the classroom due to COVID 19. Obviously, we all know at a university that education is a means to improve one's station in life. But so many of our schools are resource limited that it's very, very, very difficult to deal with. So we typically go into area schools here with IIT students, or Illinois Tech students, as we like to call ourselves now. That's another thing that's changed over the 20 years that I've been here. And this is a problem. When we go into these schools to teach students how to code, we usually have to collect every computer within the school to bring them to the students so they can utilize them to learn to code. The schools are highly resource limited. If you go into a school in Chicago compared to a school in one of the wealthier suburbs, everybody's got a computer, an iPad, and everything. Whereas in many of the other schools, those resources just aren't available to everyone. And that's a problem until we can get more technology into the hands of students. They're very limited in what they can do. These are things that really aren't technological problems in many cases. We know how to build more iPads, we know how to build more laptops. What we don't know is how to get people to pay for it. And this is a problem. Housing's another area. We have zoning limitations, density limitations, size limitations. Portland's trying to address this by adding more multifamily homes. The previous maximum home size that you could build in Portland was almost 7,000 square feet. They are reducing that significantly. That is probably a reasonable first step. And so a one size home can now have a maximum up to 2,500 square feet. But you can also build duplexes for two families, 3,000, three and four plexes, which can go up to almost 3,500 square feet. This is an interesting idea. It may go forward, but I expect there will be a number of people who come out to protest this as it actually gets implemented. This has actually passed the Portland City Council, so it will be an interesting thing to watch going forward. But there are always limitations to this, right? Here in a city, our buildings are roughly limited to about 1,000, or not 1,000, 100 stories, and close to 1,000 feet high. Realistically, it becomes challenging to push water up higher and higher. It becomes challenging to lift people all the way to larger and larger buildings. I mean, who wants to live on the 350th floor of a skyscraper if it takes you 30 minutes to go up and down? These are problems that have to be addressed. California, people are fleeing. And one of the reasons, and I am one of those people that fled California. I left in 1996, And middle and low income people are leaving because they really can't afford to live there anymore. Okay, it's great that we have technology. It's great that we have the Apples and Googles in there. But where are the firefighters going to live? Where are the teachers going to live? This is the area that I lived in when I was a grad student at Stanford. I lived in an apartment complex towards the bottom of this screen, and the bottom left. And these homes now are all 1.78, 2.5, 2.7 million dollars. I thought they were outrageous when they were $400,000 when I lived there. Uh, how is somebody on a teacher's salary going to afford to buy one of these? How is somebody who's teaching going to raise a family trying to buy a $2.1 million home? These situations all compound themselves over time. So, what happens in California is people move farther and farther away. This puts them in contact with the forest. The forest burned down, these people get killed. It's not a good situation, and we have to come up with better solutions to many of these problems. We've had long-term problems that haven't gone away. We have weapons of mass destruction, both nuclear, chemical, and biological, that we really haven't addressed very well over my lifetime. Terrorism is certainly an issue, and it affects everything else. Our transmission system of energy, whether it's power lines or pipelines, is relatively unprotected. It's not a hardened system. If you wanted to cause all kinds of havoc, all you have to do is take the power out for a while and you can cause a lot of grief. And unfortunately, people have tried to do that, both with cyber attacks and with physical attacks where people have shot up transformers out in the West. And we're getting new term problems because the problems we've had for a while aren't enough. Over the last few months, there's been a brilliant comet in the sky, Comet C 2002 F3 Neowise. You could actually see it from here in Chicago, which makes it a very rare comet because in many nights in Chicago, it's kind of hard to see the moon. An astrophotographer took this photo. This is a 30-second exposure. And I stopped counting when I got to 50 Starlink satellites that went through in 30 seconds. Should a billionaire get to decide to destroy or pollute the night sky with light pollution and a bunch of satellites? Now, they're being put there so they can provide more internet access. That's a good goal. The question, though, is this the best way to provide internet access to some of the rural areas? Maybe we should come up with a better plan. What else do we have? New problems. Artificial intelligence and privacy on the internet. These are big areas. So here we have a nice racist soap dispenser. You wave your hand under if you have light skin and it dispenses soap. If you have dark skin, you wave your hand under and nothing happens. Why did that happen? Because the people who designed it didn't consider all use cases. We have to do better. So why can't we address these problems? Well, one of the big reasons is they involve both people and technology. And we don't have many people that work to address solutions that involve both. We have a lot, especially on a campus like Illinois Tech, we have a lot of science and engineering students. who don't necessarily spend a lot of time thinking about the potential human interactions. We need to change that. We need to get the engineers working more with people who understand humanity, because that is the best way to solve our problems. In physics, which is my home here, we have this idea that we can potentially describe the world around us as a many worlds interpretation, where all possible outcomes exist in their own universe or their own bubble of worlds with the probability with which we observe it. And as we make an observation, this other universe pops up or continues on. Um, this is an area of physics that I tend to stay away from, because to me it's kind of science mixing with philosophy, because as of right now there's no possible way to actually prove that these interactions would occur. But what I find interesting is now, in terms of humanity, we are kind of pushing out in a similar way, where we have one world in our reality here, but we have many bubbles where we're self isolating. This is problematic. And one of the reasons for doing this is just our natural ability. And from our time as a baby, and you're probably not going to hear the sound for this, and I apologize for that. These videos are hard to work with Google Meet, but I'm going to show this one anyway. I'm just going to fast forward this a little bit to get to what I think is the interesting part. So we have a little baby here, and we have a ramp. We have a uh, car that rolls down a ramp. And if the block is not on the tracks, the baby expects the car to roll through. But if the block's on the track, the baby gets surprised when the car goes through it. And the baby's highly perplexed by this. Okay. And that's kind of interesting, because as we go forth, we kind of have an idea when things are wrong, when things are problems with our world. And I'm not going to show this video because you really need the sound, and it just does not work well with Google Meet. But if anybody wants it, you can see it. It's called A Private Universe, and it was funded in 1981. So we've known that these problems have occurred since at least 1981. And one of the issues we have is we tend to create our own worlds. As we go forward and we process and assimilate more and more knowledge, we are more than willing to invent our own solutions to problems. We see a problem and we go, okay, I know enough about that. And if you watch this, there's some great problems. So the question they ask is, why is it hot in the winter, or hot in the summer and cold in the winter? And people usually give an answer, oh, it's because the earth gets closer to the sun. That's not the answer. The earth's tilted, and that's why it's summer in the northern hemisphere and winter right now in the southern hemisphere. And in December, it'll be summer in the southern hemisphere and winter in the northern hemisphere. And it's because of the tilt of the axis and how light gets attenuated. Um, Now, the last person to show up in this video and through this guy here, faculty member. Faculty members buzzwords are always a little kind of interesting because they'll come up with any explanation and throw out every buzzword that they know. So as you go forward and you throw out the buzzwords, oh, you get interference and superposition of waves, and you can come up with incredibly weird answers to problems. But those are wrong. And so as we're going forward and creating our own little worlds and bubbles, it becomes problematic because you tend to believe these things deeply. Over the past few years, I've testified under oath a number of times about energy systems, how we can build out better energy systems. And some of the questions that I've gotten during this work: will solar panels hurt the children in the neighboring school? And I answer things like, well, I'd really prefer to put the panels on top of the school rather than on pristine farmland. No, it won't hurt the children at all. That won't be a problem. The image on the left is actually an image from the Tohoku earthquake in Japan that damaged the Fukushima nuclear plant. It's actually a map of tsunami wave height as it came across the Pacific Ocean from Japan to the Pacific coast of the US and the Pacific coast of South America. But people put this out as if it's a radiation map going from the damaged reactor to the US and South America. And so people ask, what about the NOAA radiation map? Well, it's not a radiation map. It's a tsunami wave height map. It has nothing to do with radiation. What about nuclear waste? Well, right now we store nuclear waste safely in concrete casks at all the plants, but I think it should be recycled. But these are all interactions of technology and people, because it's hard to convince people that this isn't a radiation map when they want to believe it's a radiation map. When people want to believe that nuclear waste is incredibly dangerous, it is incredibly dangerous to them. If somebody wants to believe the solar panels are going to create death rays that kill students in schools, they want to believe that, and people put themselves into these bubbles. And somehow we have to be able to penetrate these bubbles. We have to pop the bubble wrap around them. I think one of the reasons that this occurs is we've lost some grounding in reality. We have a very distracted society now. I could be on Twitter right now on my iPad, actually, while giving this talk. But we have things that didn't exist when I was a boy. When I was a boy, we worked on cars more. Why? Because there were 7 TV stations, and what else were you going to do? We took apart perfectly good cars and put them back together. Now nobody repairs anything. Every grocery store in the country had a self-serve tube tester. So you could take the tube out of your television or radio and replace it. You'd go to the grocery store, stick your tube in, find out if it was bad, and if it was bad, you opened up the drawer underneath, bought a new tube, and went and fixed it. And unfortunately, we've got a very destructive society now because it is so disposable. So we have to create and take all the minerals necessary to so you can replace your iPhone every other year, to replace your television every couple years. This is a problem. The American Chemical Society and the British Chemical Society now have a list of what elements are endangered, that there's just not enough of them to go around to meet demand. We have to work to at least recycle all the electronics that we're putting out. The other thing that's happened around 2020 is it's now become possible to publicize your bubble through social media. I can get on Twitter or Facebook or Instagram and make sure everybody in the world knows what bubble I think is my reality. And it allows me to find everyone with a convergent bubble whose bubble of reality agrees with mine. 40 years ago, you could be a lone nut. Now, there is no more lone nuts because everybody's on Facebook and Twitter. And you find the other lone nuts and you can combine and get together. And you couple that with modern travel, which has been knocked out a little bit by COVID. But now you can quickly congregate and spread your lunacy. I have been to a number of Roswell UFO festivals over the years. Why? Not because I think UFOs are flying here and landing in the New Mexico desert, because it's interesting to watch the people at these events. And somehow it's very easy to fall into conspiracy theories, uh, problems with rationality. I wish there was some simple solution, but unfortunately, I think it's getting harder and harder to solve many of these problems. So, what can we do about this? Well, remember when I said I wasn't going to say I told you so? I lied. I told you so. Uh, one of the articles that I've written of electricity is we need expert panels of scientists, engineers, ecologists, social scientists, economics, uh, to come up with a reasonable plan on how to accomplish the transition. And it's going to be a transition. No matter what we do in society, there are going to be winners and losers. Some people are going to suffer as we go through different transitions. Other people are going to benefit tremendously. If we look in energy, coal miners are hurting as we transition from coal to natural gas. Often you don't find coal in the same place where you find natural gas. In fact, most of the time you don't find coal and natural gas together. So this becomes a little bit of a problem. Coal miners can't just become oil or natural gas well diggers. Somehow we have to come up with something that gives them a path forward so they don't end up in horrible poverty themselves. And no one's going to be happy with every suggestion that our team of what I like to call humanists, people who are working on things practically, will come up with. And we will have to accept some tough but pragmatic solutions. That's one of the things that I really want us to explore in this Great Problems, Great Minds seminar. And so we have a number of societal problems: climate change, food security, energy security, education, poverty, disease. And my question to everyone going forward is, given that we can't get people to wear a mask during a pandemic, how do we push this forward? How do we get these more complex solutions if a simple solution like a piece of cloth can't be accepted by people? Well, we're going to bring in some outstanding speakers to talk about it. Next week, we have Ken Caldera, who's going to talk about climate change. We have Ambassador Bonnie Jenkins, who's going to come in and talk about international security and weapons. We have Elijah Anderson, who's going to talk about urban society. We have Costa Samaras, who's going to talk about infrastructure resilience. How can we build better infrastructure so we don't have to worry about bridges collapsing when a hurricane comes? Because hurricanes may very well get worse. We have Shamnaz Bada coming in, who will be dealing with how you can have humanitarian missions involving engineers and scientists. We have Martin Pfeiffer coming in to discuss nuclear weapons in society. We have Jesse Jenkins coming in to discuss low carbon energy systems. And we have even more people coming in, signing up to give talks in the series. I'm very happy to see the interest in people. I hope we have the same interest in our students here at Illinois Tech. And it's important that as we go forward to recognize that technology alone will not suffice. We must explore the interactions of technology with humanity. We have to determine what's the best way, and we have to figure out some way to allow that to be implemented. And in many cases now, we're running into technology that we don't necessarily completely understand, and we must determine if we should do something, not just if we can do something. We have to think about where it's worthwhile to destroy the night sky, which has been there for millennia. Things like that can't be allowed to be decided by one person. Now, our social sciences faculty can help you with these problems. And we would like you to reach out and discuss many of these issues with them. We have great faculty in this department. Professor Daniel Bliss, who looks at local and state governments and economic development, infrastructure, and transportation. Professor Hao Huang, who studies the the intersection between economic geography, urban geography, and planning. Professor Patrick Ireland, who looks at urban level migrant interactions in developed and developing countries. Professor Yuri Mansouri, who draws on complexity and uses computer models to understand land use patterns and how infrastructure affects land use patterns. We have Professor Jonathan Rosenberg, who looks at institutions and how they self-organize on scale to prevent conservation that can benefit local economy. We have Professor Ulrike Segerström, who works on a variety of topics, including ethics. Ethics is of incredible importance as we develop new AI. It is completely unacceptable to develop AI that doesn't work because of skin color. And that happens in both mechanical AI, in terms of facial recognition. This is uncalled for. We can't allow this to happen. We have Professor Matt Shapiro, and I recommend everybody follow him on Twitter. He's one of the few faculty who have a Twitter account. He works on environmental problem in the Northeast Asia, and especially looks at things affecting the Korean Peninsula. As we go from air pollution going from China to Korea, how it mixes with air pollution naturally produced, well, not naturally, but human produced on the Korean Peninsula, and who gets blamed for it. Blame is very important. We have a society that likes to assess blame very often instead of solving a problem. It's often more important in our society right now to figure out who we should blame for it. And we have Professor Rebecca Stephenson, who works on metropolitan areas, especially with public policy, trade, and regulation. And she also is an expert program evaluator. So if you're submitting an NSF proposal and you need your broader impacts evaluated, whether you're being successful, she's an excellent person to turn to as to how to accomplish that. So I think these are all major areas that our faculty in the social sciences department can help you with. We would like you to reach out to them when you're preparing proposals and ask them for advice and help. These problems that we have are interdisciplinary in nature, and we have to make sure we account for all interactions as we try to implement technology to solve them. So in the social sciences department, we're here to help you, and you can always reach us at socialscience@iit.edu. And with that, I will be happy to take any questions. Anybody have any questions?
Hi. Can you hear me?
I can hear you. I don't know who you are, though. I can't see who you are. So who are you?
My name is Akram Ali. I'm a PhD student in my final semester, hopefully.
Oh,
Um,
outstanding. Congratulations.
Thank you. Thank you. I just would like to say this was a very insightful and exciting series of presentations that you just started, and I'm really looking forward to meeting all the others. So I really thank you for initiating this, and just wonderful. Even your presentation style, it's plain, simple, straightforward, and it points to everything. So I just want to say thank you so much for starting this series. I'm really looking forward
Well,
to it.
I greatly appreciate that. I thank you for coming. And I would like everybody, because not every presentation will be the same. So Professor Caldera next week has requested that the students submit questions that can be asked of him as we discuss climate policy and its effect on humanity, and how we can get people to address these problems. So I would like everybody out there to please submit questions. Again, you can send them to me or to that socialscience@iit.edu, and we'll make sure that we collect the best ones, because we're only going to be here for an hour, and make sure that we go ahead and uh, get your questions asked to Professor Caldera.
One quick comment or question actually. Since these are going to be recorded, we can then go back and view them um, again. And are we allowed to share the lecture?
That is a great question. So this one, because it's me, I am going to post this on YouTube, because I don't care what what anybody necessarily thinks of me. I have no problem sharing this with the world. Uh, Now, it for other people that will be more challenging, and the goal is to make it available throughout campus. Um, the problem with this is, at the moment, we don't have a spot to host these videos yet. We're still working on that, but we're recording them. Hopefully, we will get them posted somewhere on campus, as well as me putting this first one out on YouTube.
Okay, sounds good. Thank you.
But we will definitely record them all, because somewhere we'll get them posted on campus. Any other questions? Well, thank you all for coming. I greatly appreciate it. All right. Goodbye, everybody.
Thank you. Goodbye.